Good morning, students, and welcome to the channel. This is the channel made for the entertainment also and for the education also. So today I am going to discuss class 10th chemistry, lesson 2nd. As we know that the summative 1 exam is going to come for all the schools all over the India. So the revision work is going on. So I am also trying my best to provide this free revision classes to everyone. So I am going to discuss today some important chemical compounds. So you have read acid, bases and salts, and you will see that last in that lesson we have to read about some compounds like common salt, sodium hydroxide, sodium carbonate, washing soda, that is washing soda, baking soda, bleaching powder, and plaster of Paris. So in that we are going to discuss about the uses and their formation. So today I will discuss the two compounds to you. So first of all, the common salt. Now, common salt, it is commonly known as table salt, rock salt, or common salt. But the chemical name of this common salt is sodium chloride. Yes, sodium chloride, NaCl. Now, it is a neutral salt and it is prepared in the laboratory by the combination of sodium hydroxide and hydrochloric acid, because we know that salt is formed when a base reacts with an acid. Now, common salt is also a salt, as name suggests, NaCl, common salt. So it must be formed by using a base and an acid. That's why I have told that it is made by the combination of sodium hydroxide, that is a base, and hydrochloric acid, that is an acid. That's why equation, you can you can revise the equation NaOH plus HCl. It gives NaCl plus H2O. And the reaction where an acid and a base react to form salt and water is termed as neutralization reaction. Now, so how we are going to obtain this common salt, since we know that common salt is your sodium chloride, but how we are going to obtain this sodium chloride, this common salt? So there are two processes, there are two methods. In the nature, by the nature, and second one in the laboratory. So in the nature, you can obtain the common salt either from the sea or from the underground deposits. Now, from the sea water, you know that sea contains a large amount of salt dissolved in it. That's why we tell the sea water as saline, or you can say saline. That is the sea water. Now, how we are going to obtain the sea water? So near to the seashores, what we are doing, we are trapping this sea water in large shallow pools and allow them to stand there for a day or two, even a week also we can say. Yes, and the water evaporates. After leaving the water standing there in standing position, the water evaporates by the heat of the sun and the salt is left behind. Now this salt obtained is not pure, it is impure salt. So it is being purified and then we get the common salt. This common salt is also mixed with iodine. We add some amount of the iodine with the salt and we get the iodized common salt, because iodine is required for the prevention of goiter. If we have lack of common salt, if we have lack of common salt, we will see that we have the goiter. So to prevent goiter, we are using the iodized common salt. Second way of obtaining common salt from the nature is your underground deposits. The large crystals of common salts are found in the underground. Yes, as rock salt. I told rock salt, and this rock salt are found usually underground as an underground deposit. So it is brown in color. Rock salt is brown in color due to the presence of impurities, which can be purified, and we can obtain the common salt. Now, what are the uses of this common salt? First of all, it is used as a preservative. If you have read about the rancidity, if you have read about the rancidity, then you must have known that salt, sugar, sometimes spices, they are used as preservatives. So common salt is used as a preservative. It is also used in manufacture of soaps. When you will see the lesson, carbon compounds, when you are going to read the lesson carbon compounds, you will find out that how soaps are prepared, and during the soap preparation we use common salt there. Then it is also used as lowering the temperature of ice. When there is snowfall, when we have heavy snowfall in some area, then we can put the salt over it, because salt reduces the temperature, and hence the salt may melt down. It is also required by our body for working of nervous system. But if you are going to have excess of the salt, or if you are going to have less amount of salt, in both the cases it is hazardous to our body. So we should take the salt in proper amount so that our nervous system can work well, and our muscles also need the salt for its movement. The most common uses of common salt, that it is used to prepare, to manufacture a large number of chemical compounds, such as caustic soda, that is NaOH, sodium hydroxide, then washing soda, sodium carbonate, Na2CO3, and baking soda, that is NaHCO3. So we will see that how we can prepare the sodium hydroxide, the one more compound today. So sodium hydroxide is an alkali. If you see the periodic table, you will see lesson 5 of your chemistry, periodic classification of elements. You will find out there that the first group, the vertical columns are called the groups, whereas the horizontal rows are called the periods. So the first group is the alkali metals, and you will find out the sodium in that only itself. So this sodium hydroxide is an alkali, and the formula says NaOH. Now to prepare this sodium hydroxide, we are using a process. It is known as chlor-alkali process. Now, why the term came chlor-alkali, we will see when we will discuss the preparation. Before that, we should know brine. What is brine? Brine is a saturated or concentrated aqueous solution of sodium chloride. NaCl plus H2O is termed as brine. And brine is only the main component here for preparing the sodium hydroxide, caustic soda. Now what we are going to do, we will take a beaker. In the beaker we are going to put the brine, and we are going to divide the beaker into two parts by semi-permeable membrane. On both the sides of the membrane we are going to put the two electrodes. One is going to attach with a plus battery position, second one with the negative. So plus one is termed as anode, whereas the minus one is termed as cathode. Now we put a key and we switch on the key. What we will find out that NaCl is going to break down Na plus and Cl minus because it is an ionic compound. You have read previously, might be you have read this one, all things. Then H2O it is going to break down H plus and OH minus. Now after passing the electric current and breaking of the ions, the sodium plus, where it is going to find out its opposite charge. So first of all, you see that chlorine gas is in the ionic form Cl minus, hydrogen will be H plus, OH will be OH minus, and Na will be the Na plus. So all are now in the ionic state. So what happens? Chlorine will try to lose its electron to form the elemental state or the molecular state. So chlorine will lose the electron, it will become the chlorine gas Cl2. Now the lost electron, it will be gained by hydrogen. So it will be H2. Now we are left with Na and OH minus. So Na will react with OH minus to form NaOH. Now the positions where we are going to get these three products, NaCl plus H2O forms NaOH plus H2 plus Cl2. So hydrogen will be formed at cathode because to get the electrons it has to move to cathode. So hydrogen will be formed at cathode. Chlorine gas is going to lose the electron, so it is going to form near the anode, whereas the sodium hydroxide is formed near cathode. Keep remember this position. The position is important. If you see the previous questions of CBSE, you will find out that these positions are being asked. So chlorine gas at anode, hydrogen gas at cathode, and sodium hydroxide is formed near cathode. Now the question comes, why this reaction is termed as chlor-alkali process? Because if you see the product, what we get? We get chlorine, that is chlor, and we get NaOH, that is alkali. So alkali also we are getting. Hence, this reaction is termed as chlor-alkali process. Now, what are the uses of this sodium hydroxide? The sodium hydroxide is used to make soaps and detergents. It is used to make papers and artificial fibers. It is used to degrease materials like metals and also to refine the petroleum. Now, the use of chlorine. What is the use of chlorine here? What we can do with the chlorine? Chlorine is used in the production of bleaching powder. We will see the element, this compound. So chlorine is used to prepare bleaching powder, hydrochloric acid, chloroform, paint. It is also used to sterilize drinking water, because nowadays what we are using, the canned bottles of water, so they use chlorine to disinfect the drinking water. Also we are getting the hydrogen as a product, byproduct. So what is the hydrogen? It is used to make hydrochloric acid. It is also used to make ammonia for fertilizers and methanol. It is also used in liquid state as fuel for rocket because it has a very high calorific value. Hydrogen has a high amount of calorific value, so we can use it as fuel for rockets. It is also used in hydrogenation of oils to obtain solid fats. Now hydrogenation, again we will see lesson 4, carbon compound. We will find out that these terms, hydrogenation. So it is used to hydrogenate the oil into the fats. So these two are today's compounds. In the next class, when we are going to come, then again I will share some more revision work, maybe from other lesson. Okay, whatever the doubts you have, you can mail me or you can contact me by commenting below in this video. Okay, so keep me encouraging that I can give more videos for you. So thank you and take care.